Hello friends, welcome back to my channel, and we are going to start a new topic which is testing of RAG application. So for that RAG application testing, we are going to generate synthetic data tested, and we are going to generate the test cases. So let's get started. Now we can generate the test data using either manually or using automated way. So let's get started, and before I start I just want to show that on my YouTube channel, if you open the playlist and open this AI generalist playlist, so here there is a lot of content on the RAG, how to build the RAG, different stages of the RAG, and also individual stage wise testing of individual RAG step. So please have a look. And before I start, the source code which I'm going to show here, that is available here. The link is there in the description. Okay, so yeah, the link is there in the description, and we are going to talk about this ragas library, which is going to help us to generate test cases using automated way. Okay, the ragas is rag assessment ragas. So let's get started now. Right, so rag test case generator and rag synthetic test data generator. Now your rag application can be huge, and it needs to be tested at each individual stage. Now we can generate the test cases manually. Right? We can write some sample test cases, but that is not going to help for longer term, and that will obviously fail for your entire RAG application testing. So there has to be some generated automated way to do this kind of testing. So we need to generate test cases, and we need to generate the test data. So manual test case generation for RAG pros and cons, and automated test case generation pros and cons using RAGs and using RAGs plus LLM. So basically everything will be using RAGs plus LLM. So let's see how it goes. Right. So manual test case generation. So what are the pros? So yeah, so if you do a manually, then you know better context, because automation will have different context. It will be generalized approach, but in manual test case generation, you will have a very core, very detailed knowledge. So high contextual nuances and exploratory discovery. Yes, you can go deep because you know the corner test cases. A deep domain expertise integration. So you need to have deep domain expertise, and that is where your testing skills will come into picture. Establishing ground truth and baseline metrics will be an additional pro. What are the cons? So obviously, severe scalability and time bottlenecks, because if you're doing it manually, so you never know how many test cases to be generated. Each individual topic or each individual module has to be given a lot of weightage and the like, and time bottleneck, because you need time to think on the test case, test steps, and those things. So there is a bottleneck of the time. Then yes, subjectivity and inconsistent evaluation. So let's say you are designing the test cases or designing the test data. You might design something today and maybe some other test cases tomorrow, and so on. So then sometimes you might lose the subjectivity. There is no consistency of thinking, given thoughts, or even if you develop everything in one day, you might get tired. So because a lot of this human or gross errors, there will be loss, inability to handle multidimensional combinatories. So yes, this is also one problem, because as a human we can think at a certain level, and we can certainly think for multi-dimension but not every dimension. So that is again a limitation for manual test case generation or even manual test data generation. Right. So now automated test case generation using RAGs or RAGs plus LLM. Right. So pro, yes. Massive scalability, rapid regression. Yes, this is possible because it's a program, so we can run it for 24 hours. Comprehensive combinatorial coverage. So as we are going to see, it will be RAG plus LLM, and then LLM has a uh, big advantage that it can process, let's say, 120 billion parameters, 7 billion parameters, 90 billion parameters, and so on. So that much comprehensive and combinatorial coverage it can give for a particular test data, particular scenarios under consideration. Consistent metric driven evaluation. So there will be some metrics and consistency that is possible using automated way. That is actually I'm saying using RAGs Python library or package. Cons. So yes, the LLM grading itself bias and blind spots, because we are going to use a generic LLM. Okay, so that generic LLM may have some biases, some blind spots, because it is a machine, so it may not know the context which you actually want. So let's say if you want to generate, let's say 200 test cases or 100 test cases, so out of which it might lose context, let's say after 50, 60, 70 test cases, because of lot of reason. So okay, so the more you rely, the more number of test cases you get generated, it might lose the bias, or I mean there will be some blind spots. So every time you have to correct, auto correct and those things, so then it might correct itself and then generate proper test cases. So this is a con. Setup complexity and maintenance overhead. Yes, so you need to know Python programming, then which Ragus library, which function, and we will also see the Ragus library version is getting changed. So there will be breaking changes. So you need to accommodate those changes. So the programming complexity will increase. Yes, so when the version of this increases, so yes, you need to update your test cases, functions, and all. So there is a maintenance overhead required. Risk of noisy or hallucinated test data. As I said, it in one shot, if you want to generate 1,000 test cases or 2,000 test cases, so it will generate, because it's a program, it's a application, so it's a machine, so it will generate. But then there is no guarantee that so things can go noisy or hallucination, and many other things. So there will be this kind of challenges. Okay, so let's see a demo, right? So that is source code is available in the GitHub and the link is in the description. Here, one point to note that I have used specific version of Ragas. Okay, that is mentioned in every file, but we'll see that. So first thing is to have the test data, to collect the test data. So there are different ways to collect the test data. So I have um, searched online, and so I'm using this Wikipedia library. I'm using this Gutenberg um, libraries. So I'm downloading some books, uh, and that huge text will act as a test data. Then this Edgar is one place where I can get some stock market related data and so on. So everything need not to be a PDF file or text file. So there can be a data which is of stock market or some mathematical things. So different variety of test data I have captured and downloaded. So let's see. So for Wikipedia, from Wikipedia I have downloaded some biographical data, then scientific technical concepts, and then historical events, let's say Industrial Revolution, French Revolution, Berlin Wall fall and Renaissance, and so on. So okay, so multiple, I think 7 to 8 type of data I have downloaded from Wikipedia. So that is available here. So if you see biological data, ebook, historical events, scientific concepts, stock market data, and some PDF files. Okay, so the huge sample data I have considered for development, I mean for testing, to have a different variety. Okay, because your RAG may be what your RAG and application under test. It might be for stock market, it might be for some financial thing, it might be for some um, book analysis and whatever different needs. So I'm just taking different dimensions of data, so it will be interesting to learn. Okay, so this code is there, you can just run this program. There's no you don't have to have any key or something, or nothing is paid, it is all free. Okay, Gutenberg is also already free. So here I am downloading the books. Okay, and there's a book number for this, you can find it on their website, and then from there you can download. Okay, so Gutenberg .org files book id /book id hyphen readme.txt. So with some permutation combination you can download some interesting books. I've downloaded these 3 books. Okay, so ebooks, Pride, Prejudice, yeah. So all downloaded as text. Okay, now Edgar. So this is a stock market, for stock market related data. I have downloaded for 1, 2, 3, 4, 5 top companies, and it will be some historical stock market related data, some there, stock market individual company level stock shares value, profit loss, and some EBITDA and those kind of financial data. Okay, right. So now we are using a large variety of data. Now let's see how to generate test cases. Okay, so there are test cases and test data. So there are multiple ways to generate um, test cases or test data. Okay, so I'm using test set generator here. This is again from RAG's application, RAG assessment. Okay, and I'm using Ulama as a uh, LLM provider because it is giving me free credits for a lot of reason. So that is why I'm using Ulama. So you should make sure you should start the Ulama desktop. The server should be running. Okay, local server should be running. So it is running on my local. Yes. Okay, right. So ways of test case or test data generation. So let's say there is some test data. So evolutionary query generation. Okay, so use the Ragas framework to transform simple seed questions into complex ones using evolutions like reasoning, for example, required logic, multi-context, merging info from different chunks, and conditioning. So adding constraints. Okay, so this is one way to generate the test data or test cases. Okay, right. So for now I'm using historical data path. So historical data path, and from there historical data path I'm choosing this one, French Revolution .txt. Yeah, French Revolution.txt. I can take it some other example, but for now I'm just using this French Revolution. So if you see, there is a huge data. Okay, it's a huge data, right? So what I'm doing here, I'm doing evaluation query generation using Ragas. Yeah. So, okay. So this is a way to generate the test cases automated way. Now the thing is, I can show that how to generate the test case. I mean, you can simply say that, um, let's say, if you want to do manually, so financial crisis and widespread social distress led to the convocation of estates general in which year. Okay, so this could be one question or one set of test data, and the answer would be in the year of 1979. So if you see this simply one question, let's say it's a fixed straightforward question and straightforward answer. There can be a way that I can use some, like, a question which will need reasoning, something which where I need to do, you know, I need to refer to multiple chunks or multiple places and then come with the answer, and then some conditioning. So if this happens, then what this? If they did this, then what should happen, and like that. So I like that I can generate multiple cases manually. Okay, but as I said, manual test case generation is having gross error. I might have different context. If somebody else is designing test cases, they might have different context. There will be different approach from customer or the client who is going to use. So let's go with the automated way. Okay, right. So the other settings, I need to load the directory where all the documents are available in the .txt, .txt extension, and I'm going to generate that into a CSV file. So this CSV file, I'm just going to delete for now. Okay, so what will happen at the end when I run this? The question answers will be generated in a CSV file with some sample format. Okay, so I need to generate the Olama key, and I need to use the Olama server. So I'm using a remote one, and yeah, I'm using this model which is GPT OSS 120 billion parameter, which is fairly good. 120 billion parameters. It is good number of parameter handling. Yeah. So this is to be noted. So I'm using Ragas version 022. Okay. So if you see here, I'm using Ragas 022. So there are additional versions available. Okay. V 039 is also there, the latest in the market, but this I found to be stable, which is sufficient for my current need. So that is I'm using V22. Okay. Right. So Okay, and just to show, this is the PDF content for different set of data on which I will be applying the RAG. Okay, right. So LangChain again, same exact version, and this is the exact version. So for simplicity, whenever you are doing requirement.txt, right? So here also I mentioned or hard coded the version numbers. Okay, that is to have safety, because I found a lot of issues if I upgrade the Ragas or upgrade the Olama, LangChain Olama. So what happens? This updates, but this assumes that this will have some latest concept. This will have some latest library. Now this will update sometime, but this will not update. This will not update, and there will be breaking changes. So for now, the all the compatible versions are the one which are mentioned here, and that is what I'm using. So this will make your life easy. Okay, right. So Olama embeddings, those has to be done. Then I will be generating the queries or questions or queries. So I will be generating them with three types. So total test cases I want to generate as 10. Okay, test case size. So total 10 test case I have to generate, out of which 80% should be abstract query synthesizer, 10% should be comparative, and again 10% should be specific query synthesizer. So you can, so using this ragus, you can divide this into this different what do you say, types of test data or test case generation. Okay, so comparative, so I want to go give for now weightage to abstract query synthesizer. That is what will be the highest priority. 8 test cases and one test case each. Okay, so this is a sample code. Once you this data set is generated, then I'm going to print the input, reference, context, reference, and synthesizer name. Okay, so this is the synthesizer name which will be printed. Okay, so let's run this. Now this is again Olama based, so it is going to generate some data and pass it on to Olama. So it is going to make a remote call to Olama server, and then raise a request, and then Olama will process it and it will generate the response. Okay, so if you see there is a um, percentage progress happening here. Okay, so this happens because there is an async module sync is happening, and again it's a remote call to a remote Olama, so these things happens because it is going to talk to Olama remote, that 120 billion parameter cloud hosted AI model from Olama. So it might have some problem in generation test data. Let's try again. Okay. Yeah, these things happen, so need to be patient. Let's do one thing. I will go for, okay. So just to showcase, so what will happen is once we do this, that will be dumped into a CSV file, and luckily I have this CSV file copied already here. So now what will happen is once you do this, then a sample will be something like this. So there will be 10 test cases generated, and the type will be synthesizer, the type will be abstract uh, query synthesizer, and so 8 test cases like this, 10% that is one test case, and specific query synthesizer. Okay, so now let us see user input. So randomly, let's take this one. So what series of events caused the French monarchy to be replaced by the First Republic between 1791 and 1793? Okay, so it's a straightforward question. Okay, it's abstract query synthesizer, and there's something called as reference context, and there's something called as reference. So this is the way I asked the LLM to give me the output. Okay, so if you see here, I wanted output in the format which I wanted. Yeah. So data set. Okay. So this method, right, generate with LangChain docs. It will return in the format which this is the standard format: user input, reference, context, references, and synthesizer name. So these three are useful. So this way you can generate the test cases where to a particular text. Okay, so French Revolution. So this is the entire text. So the RAG is going to evaluate it, and you are going to ask this question, and this should be the reference from which the answer should be generated or augmented, and this should be the reference. Okay, right. So that is one way to generate the test cases. Okay, you can give it a try later. This should be working fine. That is the reason I am using the older version, little older version, which are all compatible, and you can see the CSV was generated long time back. Okay, right. So let's move on to the next one. So another way to generate test data or test cases is backward context question extraction. So instead of asking questions first, extract key facts from your existing knowledge base and prompt an LLM to act as a user to generate questions that only those facts can answer. Okay, interesting. So first you generate the uh, first you ask question. I mean, instead of asking questions, you generate the key facts, and they generate questions based on the key facts, so that the answer will be from the key facts only, right? So this is also one way, just a twist, but it is also a good way. So again, this is using LLM. I'm again using the same GPT OSS 120 billion parameter or LLM from Olama because it is almost free, and some I'm using historical data path, and I'm using this prompt. Okay, so right. So again, this is a little bit off the topic. So prompt engineering is also one good topic to understand and learn. So prompt is basically we are asking an AI model that, so behave like this. This is the input and this is the question, and give me the model answer. Okay. So act as an expert at creating diverse and challenging question answer pairs from the text that will use used to that will be used to evaluate a retrieval augmented RAG, I mean retrieval augmented generation system. Okay, and so on. So yes, I want to generate 10 test cases. Okay, these are the test count and include different question types of factual, in inferential, analytical. Difficulty should be basic, complex. Test understanding of key uh, concepts, relationship, and implications, and so on. Now, at the end, because it's a prompt, so I have to tell that generate the response in this format. It should be in JSON format, and it should have the key as user input, reference, context, references, question type, and difficulty level. Okay, so we difficulty from basic to this thing, and question type should be factual, inferential, or analytical. Okay, right. So only thing is the count should be 10. Okay, right. So again, I'm as I said, using historical data. So this is very easy because I'm going to give everything to Olama, and there's no RAGs coming to picture. There's no RAG assessment library. Everything is using um, Olama. Okay. Now Olama uh, being very stable AI model for now, this 120 billion parameter. So this is going to generate us a very good response. Okay. Right. So let's see. It should not break. The code should not break because there is no Ragas coming into picture, and it is directly asking the Ulama with a prompt. Okay. So one more thing here is basically I'm using the historical data path, right? So historical data path, so again the same historical data path, and there will be French Revolution.txt considered. Okay. Right. So now if you see, I asked for 10 test cases or 10 test data set. Okay, but let's see what happened. So right, so user input, reference, context, reference, question type, difficulty level. Okay, so basic recall. So there will be 5 test cases which are having basic recall. Then complex reasoning, there will be 5 test cases with complex reasoning. Okay, so 50-50, right? Okay, so let's take some random. For example, this one, user input should be approximately how many people were sentenced and executed during the reign of terror. Okay, so reference context will be about 16,000. Reference will be about 16,000. Question type will be factual because there's a number here, and it is asking some definite tentative number. Difficulty level is basic recall. Okay, like this. So now you can generate the test cases or test data either using Ragas, okay, in a proper manner, okay, or you can go for the Olam, right? Olama.generate method. Okay, so you need to pass the model, GPT OSS model, and the prompt, and no streaming, and format response should be JSON format. Okay, all right. Now next one is LLM. Okay, right. So now because we went for a sample LLM. Okay, so now then there can be different aspects. Okay, because LLM is doing all the backend work for us, all the formatting, the test, context, discussion generation, text embedding, chunking, everything. So now we have a upper hand that we can write different types of prompt. Okay, so yeah, test data or test case generation. So persona based simulation define various user personas, for example, a novice student or expert analyst, and prompt the LLM to generate the question in their specific tone and complexity levels. Okay, right. So LLM is very powerful. Only thing is you can host it locally. It will be it will be consuming a lot of RAM and processor resources, or you can go for the paid one which is remotely hosted like Olama. Again, it is giving free credits, so that's why I'm using. So many people are using uh, OpenAI model or Cloud or other models. I'm using Olama because it is giving me free credits. So to this Olama, we can generate, we can send out a prompt which is based on this. Okay, Right. So example of how to define and pass the persona. So persona type would be expert, scientist, or novice. This thing. Description should be focused on technical implementation, edge cases, and performance metrics. Okay. So this is a prompt. So you are an expert at creating diverse and challenging question answer pair for RAG evaluation, and some standard uh, uh, data passing. This is the expectation, this is the task. Constraints, response format, I want response to be in JSON format, and again these are all in JSON we have a key value, so these are all the key and the corresponding value should be generated. Okay, right. Now like this there will be another prompt, another way of generating test cases. So multi-hop reasoning synthesis. Okay, so explicitly instruct an LLM to find two related but separate documents and create a question that can only be answered by collecting information from both. Okay, interesting, because it is trying to make things bit complicated. Multi-hop reasoning. So again that will do that will test your RAG in a different dimension. Okay, right. So again some prompt is here. Then yes, adversarial and edge case generation. Okay, so prompt a critic LLM to generate tricky questions, such as questions with no answer in the context or ambiguous phrasing, or questions designed to trigger hallucination. Okay, this is also interesting. So there will be many ways you can generate test cases, and this is unlimited, so you have to decide where you want to stop. Okay, again there is a good prompt here, so you can go through this prompt. Okay, the source code is available here. Source code link is in the description, so it is good. You can have your own prompt also, and that way you can also continue. Okay, right. So so far we have seen a lot of things, so using automated way, using manual way, okay, and so on. Okay, so I hope you like the content. Please let me know in the comments if you have any questions or doubts. Happy to discuss more, and please like, share, and subscribe to my channel. Thank you.